We're going to do our second problem with continuous Fourier transform, looking at this function here. So we can see clearly, and let's define some of our critical parameters. We go up, down, then repeat at 3. So we go up, square, down, repeat. So our period here is 3 seconds. So then I know my f equals 1 over 3 seconds, so 1/3 hertz. And I know that my delta f, or my f max is just going to be my whatever my highest order harmonic is times this delta f. So we want to calculate our harmonic coefficients, and let's go ahead and let's consider up to n equals 10. First 10 harmonics. So we need to attack this problem just like we did previously, and luckily below here we have the functional forms of our kind of 3 piecewise functions. So I'm going to say t equals 3 seconds. Make sure that you keep your units consistent. Delta f equals 1/3, or equals 1 over t. Let's keep it general. And my y sub 1 equals 10t. My y sub 2 is equal to 10. And my y sub 3 equals minus 10t plus 30. Let's just double check that right here. And that looks good. So calculate my harmonic coefficients to figure out my, if I want to plot my Fourier spectrum or my frequency spectrum, I need to figure out and calculate my a sub n. So just like last time, 2 over t, and then we need to integrate my y sub 1 times cosine of 2 times pi times n times t divided by t. And then I'm going to integrate from 0 to 1, from t goes from 0 to 1. And I'll go do the same thing for this. Integrate here, plus here, plus here. Close it up. I just need to make sure, hopefully I don't do any silly mistakes like I'm prone to do in other videos. If you go too quick. So 2 to 3, my limits of integration, and my y sub 3. That's it. So this is my a sub n. If I want my a sub 0, but I'm not going to actually do that in this video because I'm not going to be concerned about that 0th order harmonic like we talked about in class. I can just get rid of this. We might need that for a little bit later on. Anyways, let's do my b sub n now. So my b sub n is equal to here. Same thing. I could do full simplify. Full simplify right there. And we get a little bit nicer function. B sub n, the only thing that's going to change here is my sign. So sine, oops. Let's do sine, and then let's do sine here. Let's do full simplify. I don't need to calculate my b naught because I know that's going to be 0. Full simplify. And there I've got it. So I want to do my, so this is my f series. So my frequency spectrum and my x-axis is just going to be a table from n times delta f. From n goes from 1 to 10. Just that. And then I'm going to do my c of n. Cn's equals, actually I'm going to play around with this function. A quick square root of an squared plus bn squared slash dot n goes to 1. All right, so that'll work. And I'm just going to do a table. Do this. Little different code each time. Sometimes I get bored and I forget what was my previous method. That's why mathematics is so fun. You could do multiple times different codes each time. So anyways, let's go ahead and transpose these together. I'm going to do transpose. And I'm going to do my f series and my cn's. So that's my magnitude. And then I'm going to do my list plot. Do my frame true, frame style, directive, black, bold, 50, thickness, 0.005. In the next videos, I'm gonna just copy. And then now we're gonna do each side's 1,000, plot range all. And then I'm gonna do my list plot second here, or actually plot style. I'm gonna do that directive red point size 0.05. That might be too big. And then filling style bottom. Let's see. So now I'm going to go here. I'm going to go zoom out. And actually, let's do fill. There we go. And as I might have anticipated, it's a little bit too, not this. And it's a little bit too. How about 0.01? Yeah, it's okay. So, but anyways, we can see that we recover our frequency spectrum like we see here. So looks like it did all right. So we know, again, what's the maximum frequency, what's the lowest frequency, what's the dominant frequency, and that's going to be the dominant frequency, highest amplitude here. So our dominant frequency is also our fundamental frequency. So next video, we will graph the Fourier series, and we'll be done with lecture 6. So I'll see you in the next video. Thanks. Bye.